There are three tests we can do to see if a distribution is normally distributed. First, we can simply look at the distribution. Does it look normal to us? Well, this is a perfectly normal distribution following the empirical rule, 68%, 95%, and 99.7%. This is a great example of a normal distribution. Unfortunately, a lot of times we don't get this, so we have to use much stronger methods to test for a normality. The second thing we can do is use the normal probability plot or normal quantile plot. With this in mind, let's look at some of those. Here we are. Well, does this look normal? That histogram looks kind of alright. And yes, the normal probability plot shows me that too. If the points follow a straight line without any bends through it, it is a good normal probability plot suggesting to you that the data is from the normal distribution. Sometimes we call this the fat pencil test. We can take a pencil and lay it down right here, and if it covers up all the points, that means the data comes from the normal distribution. But if we have one that bends, that would suggest to us that there's probably a problem with normality, and we see that in the histogram. Remember, first, look at the histogram. Does it look normal? Second, look at the normal probability plot. Does it bend? Well, this doesn't look normal and this bends. That suggests to me that this isn't a normal distribution. The final test we can do actually uses real statistics and gives us a more definite answer. We can use the goodness of fit test. Now, the goodness of fit test does what it says. It tries to see if this data fits under the normal distribution. With this in mind, let's read off what it says. This stands for null. The null is that the data is from the normal distribution. Small p-values reject the null. What is a small p-value? For right now, we will understand that a small p-value is below 0.05. So in this instance, we cannot reject the null, which means we're going to stay with it. This means the data is from the normal distribution because I cannot reject it. Well, let's look at our other answers here. That looks kind of normal. This doesn't really have any bends, and I can't reject the null, so I'm going to stay with the data from the normal distribution. That all works out the same. Let's look at one a little bit different. This one has a strong left skew, first test looking at it. This has a kind of bend through it, a little more than the last one. And uh-oh, right here, JUMP puts a star to tell you that this is significant. Any p-value below 0.05 in JUMP will be starred. And as it says, small p-values reject the null. I will reject that this is from the normal distribution. So all three of these tests are the same right here. Visual inspection shows a problem. The normal probability or quantile plot, same thing, shows a bend that wouldn't be covered by our fat pencil, put on this line right here. And then the p-value is small, suggesting to us that this isn't from the normal distribution.